Hi, this is Mr. Warden. I'm going to review Chapter 3, Section 3, or 3.3, which is called Beyond CPCTC, or Beyond Kappa, Beyond Corresponding Parts of Congruent Triangles are Congruent. So it's going to define a couple of things. In particular, you've probably already heard of an altitude of a triangle. It's also going to define the median of a triangle. So let's start with just reminding ourselves what a median is. A median of a triangle is a line segment drawn from any vertex of the triangle to the midpoint of the opposite side. So if we are using A, it's like the corners of the triangle, they're the vertices. That's the vertex A right there. And if we're drawing a median, we're drawing it to a midpoint of this opposite side, the side that is on the opposite side of the triangle, complete opposite side of the triangle from that vertex. So in fact, for B, vertex B right here, the opposite side is AC. So if we did a median there, it would go to the midpoint of AC. And the nice thing about that is then we have defined a midpoint, which means we've bisected this, which if you can demonstrate you've got a median, then you have demonstrated that you have bisected it. Or if you need to demonstrate something is a median, it's useful to demonstrate that these two segments are congruent, and therefore the segment has been bisected. Okay, in alternate form, a median of a triangle divides one side into two congruent segments. Okay, so in other words, the median bisects that side. Altitudes of a triangle, well, altitudes are something you've worked with when you found the area of a triangle. So altitude is basically going from a vertex to the other side, but is perpendicular, not necessarily a bisector, but definitely perpendicular to the other side. So it is a segment that goes from a vertex to the other side. Now, sometimes that's going to be outside the triangle. Okay, so with acute triangles or 90-degree triangles, so an acute triangle being one that has all angles less than 90, or a right triangle where one angle is 90 and the other two have to be acute because they have to add up to 90. The altitude will be on the inside. However, if there is one obtuse angle, there will be at least one altitude, and probably two. There will be a couple altitudes that are outside the triangle. So basically you extend the opposite side of that this vertex, the opposite side, extend it out so that you can make a right angle. So that will be an altitude. And that's what you would use as the height of the triangle to find, it's called altitude because it's the same as height. Height of a triangle when you do base times height over 2 to get the area of that triangle. Okay, now there's another concept called auxiliary lines. Now, auxiliary lines is a really fancy way to say sometimes you have to draw some extra stuff. So if you've got this triangle with this little triangle in it, and we've got AB and AC are congruent, we've got BD and CD are congruent, we want to prove the triangle ABD, where's the rest of that triangle? And ACD, where's the rest of ACD? Well, we're going to have to draw a line. That's all it is, draw a line. So one of the things I do encourage you to do is take these things and draw them out in your notes instead of just doing it in your head. Get it out of your head and onto paper. Things will make a lot more sense. You can color code things. You can mark them up a lot better. So let's see. There is a note here about this. So as we go through, we'll often need lines, rays, and segments that do not appear in the original figure. These are called auxiliary lines. Most auxiliary lines merely connect 2 points already in the diagram, although you will see other types where you might have to draw outside. So each auxiliary in a proof needs a reason such that the line can be drawn. Okay, so you will need a reason for it, but it is a postulate that one and only one line, ray, or segment can be drawn through 2 distinct points. The word determine represents the word determine represents the idea that for 2 given points there is a line through them, and no more than one such line. Okay, and here's that posit. 2 points determine a line, one line, ray, or segment. So that's why it says determine. Okay, so then there are proofs beyond Kappa-Kadaka. Well, basically what that means is sometimes Kappa-Kadaka is not the last step. Maybe you need to go further. So here we've got segment AB, AD and segment CD are congruent. We know angle ADB and CDB are congruent. We want to prove that DB is the median here. Well, in order to prove that DB is the median, we need to prove that these two segments, AB and CB, are congruent so that we can prove that AC has been split in half. Well, we can do that because we know this side is congruent. We know these sides are congruent. I'll mark them up. Okay, so we know this side is congruent with this side, and we know that these two angles are congruent with each other because it told us they are. That's all given. Now we can also prove that DB is congruent to itself. So now we have side, angle, side. And by Kappa-Kadaka, we can prove that AB is congruent to CB because both side, angle, I should say, and side, angle, side, we can prove that ABD is congruent to CBD as triangles, and therefore AB and CB are congruent. And once we've proven that, we can prove that B is a midpoint, and therefore DB is a median, because that's the definition of median. It goes from the vertex to the midpoint of the opposite side. All right, I hope that has helped. It gives you some nice, thorough examples of practice proofs for you, sample proofs for you as well in here. Let me scroll down and see if there's anything else I want to lay out. Some of these will be familiar from Do Nows or Exit Tickets. And I'm going to stop. I hope that introduction helped you definitely walk through these sample problems to help make sense of things first.